Hey, this is Brock Lemires. In this video, I'm going to go over two-dimensional arrays, and we'll just look at basically how to set them up and how we index them. All right, so we've looked at 1D arrays, which are nothing more than a single name that represents a list of values, multiple values, and you can access each individual value using an index and the name of the array. And you can also do in C 2D arrays, all right? So just like in 1D arrays, what you do is you have to define a type of what each element in the array is going to be. So in this situation, every single element is going to be a double in this array. And then you give it a name. And then what you do is you give it a number of rows and a number of columns. So you give it two square brackets. Now we'll look at different ways to initialize this. In this situation, I actually put a number in here, but it's just like 1D arrays where you can leave them blank, you can, and then initialize it with curly brackets and just like that. Now, the way this is right now, these are going to be uninitialized, but let's take a look at how it works with rows. So in terms of the row numbers, you basically are going to have 0, 1, 2. Those are your indices, and they are what correspond to the first square bracket. So it's basically a row goes left, right. And then you're going to have columns. So in this situation, you'll have an index for column 0 and an index for column 1. So a column goes up and down. So then you can access or address each element in the array using its row column. So think about it like this: X, Y. So you always do XY coordinates, not YX. You do XY. And what you do here is this would be considered 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. Okay, so it's just like XY coordinates. Okay, so let's code it up. Let's go ahead and change into our mod 08 directory. I'm already logged into the Linux server. And what I'm gonna do is I'm gonna take a look. I got all my little files that I've been creating to learn about arrays. I'm gonna create a new file called 2darrays.c. And then what I'll do is I'm in Vim, so I hit I to get into insert mode, and I'm going to say experimenting with 2D arrays, comment header as always. And then what I'm going to do is I'm going to do pound include standard.io.h so we can use printf. And then let's do the shell of our main function. So int main void open curly, come on down, return 0. And close curly, save it up, life is good. All right, so here's what we're gonna do. Let's just create a 3x2 array. Let's manually initialize it and manually print it, okay? And we're gonna use some copy and paste here, and I'll walk you through that. All right, so we're gonna go, let's create one that is a double, and it's gonna be called M for no reason. And we'll go matrix, 3x2, and done, okay? All right, now going down here, the reason I made it a double is I'm going to do this kind of weird thing where I'm going to use 2 digits and basically put like X, Y. So I'll have like X.Y. So you can see the address of each kind of just in a cheesy way. But anyway, I'm going to do this M, and you can absolutely type in the index manually. So if I do that and I say 0.0, that is going to put the value, the number 0.0 into this location right here. It is row 0, column 0. Here's what I'm going to do, if you don't mind. I'm going to hit escape, and I am going to, now I'm in normal mode, I'm going to hit YY to yank the line. And then I'm going to hit the button P, and I'm going to do it again, and then I'm going to do it again, then I'm going to do it again, then I'm going to do it again. And now I have 6 statements. And now what I'm going to do is I'm going to come through here. I hit escape, and I'm going to use the lowercase x to delete certain things. I'm going to come over here, and I'm just going to do this. I'm going to come in here. Now I'm going to come back, and I'm going to go 1, 1, 2, 2. Okay. Then I'm going to come over here, and I'm going to get into normal mode. I'm going to use the lowercase x, delete that, delete that, delete that. I'm going to come back up here and go 1, 1, 1. And in this way, I have now cycled through all of the possible indices for the 2D array. 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. So all the way through. And then what I'm going to do is come in here and I'm going to update these, and then I'll print them. Okay. Now you can see right away, it's like, man, we got to get to loops quick. But I just want to show you that you can do this because you can. All right. And then let's do same thing. Just let da, 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 da. All right, feels okay. All right. So now I'm going to do this. And now I'm going to do something that is even more copy paste-ish. And what I would like to do is the following. Okay. I'm going to, no, I'm not. No, I'm not. I'm going to do this. I'm going to go, I was going to try to block copy that, but print out. Okay. It's going to be easy. I'll just do print F. I'm trying to figure out what would be easy. M0, 0, and then equals, and I want to print this number. So I'm going to use, it's a long float because it's a double. Try to get that on the screen. And then what I'm going to have is I just want to put one decimal place. So I'm just going to go format specifier %.1, and then I'm going to go long float. Okay. And then I'll return it. Okay. Now I need to put what value is going to be substituted into the actual format specifier. And in that situation, I'm going to literally go M0, 0, and I'm done. Okay. Not even close. Okay. Let me go over here. Delete that. Okay, at this point we've typed enough. Let's compile this and make sure that this at least prints the first value. So I'm gonna come in here, I'm gonna change it to mod 08. All right, and then I'm gonna do GCC 2D arrays, direct the output to a executable called 2D arrays. And I'll nuke the little thing off there. And then I'll go, if I do it with wall, it's probably going to say I'm not using all my variables. Yeah, no. Then I'm going to run it. So I'll go Sunny Holland, 2D arrays, and off we go. Segmentation fault. That's fun. Okay. Let's see. Why did that happen? Core dumped. Okay, so core dump. What that usually means is that you're accessing an area that's outside of what you've set up. So if I came out here and I'm like, oh man, I typed 3 there instead of 2. That was supposed to be 3, or excuse me, 2. Since I accessed an area outside of what I had initialized it, the computer said, nope, sorry, you're out, and it just dumped my whole program. But it did print it before it did that. It dumped it, so that was nice. All right, so let's do this again. GCC. No core dump, life is good. Now let's come up here and go YY 1, 2. Actually, I'm gonna do this. Watch this. I'm gonna go over here. I'm gonna do 1, and I'll go over here and go 1. You can see what I'm doing. It's just like repetitive here. So I'm gonna go YY P. That's my 1, 2, 3. And I'll come up here and go YY, and I'll go P P. Okay, so we got 6 printf statements. Yes, this is taking a lot of time to do this. I don't know if I should have done it. No, it's awesome. You gotta prove to yourself that this works, right? And then I don't know why I keep typing 3 there. Okay, so good. And then we just gotta do this. And what we're trying to do here is prove to ourselves that this works. Because once it works, then we can start using loops. Okay. All right, so let's come down here, compile it up, run it, no segmentation dump, and we are good to go. All right, so we were able to access each of these with a hard-coded index. We were able to get 00, 01, 10, 11, 20, 21, and it proves to you the XY location column versus, or row versus column syntax. All right, loopers. Now, here's what's interesting about loops. You got 2 dimensions, so you need to actually use 2 loops, one of them to go through row, one of them to go through column. And so let's watch how we're going to do this. All I want to do is let's create a loop that'll now print this. So I'm going to come down here and go print. Let's go now print with loops. And I'll come over here and I'm going to do this. I need 2 loop variables, I and j. And I'm going to do this. For the first loop is going to be used for the row. So I'm going to say I is equal to 0. I is less than, in this situation, our row is going to be less than 3, meaning it'll go 0, 1, 2. And that's what this is right here. Okay. And then we're going to go I plus plus, and then we'll go ahead and open a loop, close loop. Okay. Then underneath it, we're going to nest a loop, which is going to use the j variable. And this is what's going to go through the columns. So we'll sit with the row using I, we'll go 0, and then we'll use K to go 1 or 0, 1. And then we'll let I go to 1, and we'll use J to go 0, 1. Okay, so now in this situation, what we do is we're going to go J is equal to 0. J is less than 2 to allow it to only increment 0 and 1, and then J plus plus. Okay, now with double loops, you got to be very careful because, let's come down here. It's easy to make a typo. So one good thing is always align up your curly brackets with the actual statement you're in. So now let's do a printf statement, and let's do this. I'm going to go M, and let's put in the index itself. We're going to actually print out I and J. So let's put format specifier %D, then format specifier %D, and we're going to put the integers I and J in there, and then we'll just go equals, and we'll do format specifier .1 long float, and then return. And this will print out basically almost the same thing as before. Now what I'm going to do for my variables, I'm going to do a line, I'm going to hit return I, J, M at I, J, and good to go. Okay, so let's see what we get here. All right, so I'm going to come over here, and I'm going to compile this little fella up, and I'm going to run it. Lo and behold, it's the same information. Now, it was really hard to see, so let me do this. I'm just going to do a printf, and let's do a couple line returns before that example and this example. And then now we're feeling a little better. So let's go ahead and that'll differentiate it. And there we go. So that my last stuff was up there. So I got 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. It worked. Now, when you do 2D arrays, you're almost always going to be using nested for loops. So you kind of got to get used to it. Okay. Now let's go and look at how you could potentially initialize these things other ways. Okay, so let's do this. I'm going to do curly knit. Okay, so let's create another array that's int, and this time let's make it n, and we'll call it 2 rows, 3 columns. So this is going to be a little bit different. And I'm going to initialize these with the curly brackets. So here's how the curly brackets work. You list the row values in curly brackets within the entire curly bracket. Okay. And what I mean by that is if I did 1, 2, 3 curly, okay, and then I came over here and I commented, what this does is once you open the curly, it's like, okay, he's going to initialize the array or initialize the 2D array. This will be the first set of curlies will be this first row. All right. So now I can come in here and I can do, all right, let's do the second row, 4, 5, 6. And then I close the whole thing up and I'm ready to go. So now what I've done there is I've initialized it as 1, 2, 3, 4, 5, 6. And now to prove that, I need to print it. Now here, bear with me. You ready? I'm going to do a block copy. Now, here we go. I'm going to hit escape. I'm going to put my mouse where I want to start copying. And I'm going to hit V as in Victor. I'm now in what they call visual mode. I'm going to arrow down all the things that I want to copy. And once I have them highlighted, I'm going to hit the button Y. That yanked it. Now I'm going to come down here and I hit the character P for paste or put, and I'm up and running. So now I have this sweet for loop copied. I just need to adjust the indice ranges based upon this. And then I'm going to update that. And then I update this to be the new variable name and get all the spaces out of there and make it pretty. And we should be able to see this. Okay, so let's go ahead and run it. So GCC up, we got all sorts of weirdness. We copied and pasted, the print statement was a long float before, but now we're doing an integer example. So let's do it as %d to print the integer in decimal. All right, so go back over here. Got it. Run it. Oh, baby. 1, 2, 3, 4, 5, 6. So that's exactly what I wanted. 1, 2, 3, 4, 5, 6. Okay. All right. Now, just like with 1D arrays, if you didn't list anything, like you listed some, as an example, like what if I came in and I did this? I only initialized like the first row. That's fine. That'll actually initialize 1, 2, 3, but the rest of it will be initialized as 0. So that's actually perfectly valid to do. So if I GCC'd it and ran it, notice that these are now 0, 0, 0. That's absolutely fine. And if you did nothing, like if I came in here and did this, Let's see if that would work. It would initialize everything to 0. So this is a good idea to do that. Okay, what if I wanted to print this like the way that they actually look in our minds in terms of an XY? Really, all you need to do is think about the way that we print the line returns. So if I have a for loop and I'm going to loop through the rows, this for loop right here is going to be I, and we're going to let it go 0 and 1, but then J is going to go 0, 1, 2. So we really don't want to put a line return after each time you print the number. So let's do this. Let me just actually get rid of the little notation that we had in the last where it said N00 or XY. And I'm just going to print the number, and then I'm going to put a tab. Okay. And then I am not going to put a return. Now I'm going to put this on one line now because it's not that long. So I'm going to now move this up, and that'll be useful in a second. So I'm going to write that, and then let me go like this, close that, delete that line. And now think about what's going to happen. It'll print everything on one line. So let's test that. So I GCC it, I run it, and it's like, oh, interesting. First of all, these values kind of suck because we deleted them all. So 1, 2, 3, 4, 5, 6. Okay, much better. Now they're initialized. So let's look at this. GCC, run it. Okay. 1, 2, 3, 4, 5, 6. All we got to do is put a return, a line return, after the first row. So where in this for loop is the first row? It's after this for loop right here with the J completes, but it's before you go back to this for loop for the I. So this is the row for loop, and this is this is the column for loop. So it goes 0, 1, 2. This is the row for loop. So all you got to do is come over here and do a printf at this level. So I'm going to say printf. Actually, it's actually aligned with this. So it's printf, and all I'm going to do is just say line return, done, and then let's do this. Boom. And it's like, oh, 1, 2, 3, sweet, I got it. Isn't that cool? So you can print it the way that we think about it. All right. Now, if you wanted to waste a tremendous amount of time like I did once, you can actually try to put like the matrices around it to make it look like a matrix with these little sticks. I don't know why I did this. I spent so much time trying to format these using this code, and when I got done, I regretted doing it so bad. So if you have a few minutes and want to just play around with trying to like print stuff and get it to look a certain way when it prints to the console, go ahead. It's just for fun, and after I did it, I can tell you it wasn't fun at all. So that is it. That is an introduction to 2D arrays, and see ya.